In the vast expanse of the cosmos, where stars collide and black holes lurk in the shadows, there exists a cosmic phenomenon that has baffled astronomers and astrophysicists alike. An enigma that remains one of the most tantalizing mysteries of the universe. These high-energy cosmic signals have captivated the scientific community and ignited the imagination of stargazers around the world. But what causes these ephemeral flashes of radio waves, and what secrets do they hold about the universe's most powerful and enigmatic events? Join us as we delve into the heart of the cosmos, seeking answers to the profound questions raised by these celestial flashes. Fast radio bursts are transient energy explosions that are more brilliant than whole galaxies, yet their origins are still unknown. Here are some things about FRBs that we know and don't know. Intense radio wave bursts, known as fast radio bursts, FRBs, may release as much energy in a matter of seconds as the sun does in 3 days. Many aspects of these incidents are still unclear, though some have been found at frequencies as low as 400 to 800 Hz. FRBs are found across the sky and have frequencies of around 1,400 Hz. According to some experts, 10,000 FRBs might happen every day at random locations throughout the sky above Earth. Nevertheless, the majority of FRBs only last a few milliseconds, and by the time their energy reaches Earth, it is 1,000 times weaker than a signal from a cell phone that would be detected on Earth if it were released from the Moon. FRBs are very hard to see since these signals are so short and feeble. Thus, a great deal regarding FRBs is yet unknown. Researchers are unsure of the precise cause of FRBs. Magnars, fast-spinning neutron stars with strong magnetic fields, merging white dwarfs, dim, dense stellar remnants, collapsing neutron stars or bitsars, and colliding galaxies are among other suggested possibilities. But there are several things we know for sure regarding FRBs. These brief radio wave bursts have two purposes. First, they need to originate from very powerful sources. Second, throughout their journey, they may collect data about cosmic settings, such as the interstellar gas clouds they pass through. That's why scientists who want to map the cosmos must prioritize investigating FRBs. When an FRB burst out of the small Magellanic Cloud, a Milky Way satellite galaxy, Australia's Parkes Observatory was the first to see it. But it wouldn't be until 2007, when astronomer Duncan Lorimer and colleagues detected this occurrence in archived observatory data. In a report the same year, Lorimer and crew referred to the FRB as a bright millisecond radio burst of extragalactic origin. The first known FRB was formerly called FRB 010724, although it would subsequently be dubbed the Lorimer burst in his honor. Additional research has shown that the Lorimer burst, which lasted for around 5 milliseconds and did not recur, is still among the brightest FRBs discovered to date. The Keen burst, or FRB 010621, was the second FRB to be discovered. It was discovered in 2011 using data from the Parkes Multibeam Pulsar Survey. In 2012, the first repeating FRB, FRB 121102, was found at the Arecibo Observatory, a decommissioned radio telescope located in Puerto Rico. This finding verified that the source of these intense radiation bursts survived the emission, at least in some cases. Some catastrophic FRB models, such as those involving rare events, were deleted. This confirmed that an environmental anomaly near the Australian Observatory didn't cause the accidents. It was particularly notable because FRB 121102, which seems to have come from a galaxy 3 billion light-years away, was the first FRB identified by a telescope other than the Parkes Observatory. This confirmed that an environmental anomaly near the Australian Observatory didn't cause the accidents. The California Institute of Technology coined the term fast radio burst the next year to describe this kind of occurrence. Despite being the first found, these FRBs are not the oldest. In June 2022, astronomers found a 13 billion light-year distant FRB using the Australian Square Kilometre Array Pathfinder, a radio interferometer with 36 12-meter antenna dishes. As a consequence, FRB 20,220,600 antenna, the most distant and oldest FRB yet detected, may have been launched where the universe was less than 1 billion years old. Not all FRBs are distant. The Milky Way is not the source of most FRBs, including those previously listed. Discovering an explosive event from our galaxy is significant. The Canadian Hydrogen Intensity Mapping Experiment and the Survey for Transient Astronomical Radio Emission 2, which uses 3 California and Utah radio antennas, identified the burst in April 2020. It was FRB 200,428. It was 1.5 milliseconds long and originated from 30,000 light-years away near our galaxy's core. The longest FRB ever found was FRB 20,191,221, discovered by CHIME scientists in 2019. It took 3 seconds, about 1,000 times longer than the average FRB. Besides recurring peaks, its discoverers called it a cosmic heartbeat. Repeating and non-repeating FRBs are distinguished clearly. More than 1,000 FRBs have been seen since they were discovered. Only 140 FRBs have been found up to 2017, 10 years after the Lorimer burst was detected, according to McGill University. CHIME, which discovered an astounding 535 FRBs in 2021 alone, altered this. Most of the FRBs that have been found so far are not recurring. For example, just 18 of the 535 FRBs that CHIME discovered were recurring. With the use of CHIME, astronomers were able to triple the number of known recurring FRBs from 25 to 50 in April 2023. Astronomers do not know where these FRBs come from because they only last a short time and do not happen very often. They cannot use a second occurrence to figure out where the FRBs are coming from. According to some experts, the reason there may not be many repeated FRBs in the FRB catalogue is because we haven't watched the sky long enough to find many of them. However, there seem to be some differences between recurring and non-repeating FRBs. According to McGill University, non-repeating and repeating FRBs may come from different places, since repeating FRBs last longer but cover a smaller range of radio wave frequencies. If you've enjoyed this celestial exploration, don't forget to like, share, and subscribe, and stay connected to the wonders of our ever-expanding cosmos. Until our next journey, may you continue to gaze up at the stars with wonder, for the universe, like the FRBs themselves, never ceases to astonish us with its boundless mysteries. Thank you for joining us on this exhilarating quest, and as we conclude, remember that the celestial flashes are but a small fraction of the awe-inspiring tapestry of the cosmos. If you have any suggestions, then feel free to tell us in the comment section below.